In this lesson, we want to look at how can I describe and work with geometric solids. So when you're thinking how to work with geometric solids, you're really first thinking, what is a geometric solid? Well, it's three-dimensional. They're three-dimensional figures with length, width, and height. So if I were to quickly do that, you might have length, width, and then height. And then you could even potentially connect these all, and then all of a sudden you're like, oh wait, look, I have a cube. Nice. So the next thing you'd want to look at is how do we represent these? This is technically only 2 dimensions, but so what we use is a net. A net is a 2-dimensional representation of a geometric solid. Now that being said, this is not a net. What a net would look like would be something that you could probably cut out and potentially fold into it. So you would cut the net out as a single piece, and then you'd be able to represent all the sides and fold it together. So right here, I've started to draw the net of, say, a cube. Now in this one, we only see 1, 2, 3, but this wouldn't be able to be cut out to be a cube because we know that in a cube you have 6 sides, or 6 faces is what the word that you're going to use for that. So you need to actually have all 6, and the way I would draw it is I would have 1, 2, 3, 4, 1, 2, 3, 4, 5. No, sorry, I did that wrong. You need 4 like this, and then the other 2 would be the top and the bottom. So you can put those anywhere, one here, and then you can put another one here, and then you would, in theory, fold this over, and it would be able to turn it into a cube. Another word that you might want to know is a prototype. That just refers to a model or something that something to represent something, like a first example. It's a working model of a possible new product or something. All right, so there's 3 other important words. These are probably some of the more important ones you're going to hear when you're talking about geometric solids. You have an edge, which is the intersection of 2 faces, kind of like a corner, but it's more of a line. And I'll show you an example in a minute. You have a face, which is one polygon that makes up, a polyhedron. So polyhedron is just a synonym for geometric solids. Vertex, the point where edges meet. So edges and face and vertex all kind of used to define each other. So I'll draw a little cube again and then point out where the edges, face, and vertex are. So if you're looking just for the sake of knowing how to do this, it's a quick way to sketch out a cube. It's not going to be perfect, but if you draw a hexagon like this, somewhat of a regular hexagon, and then you kind of find the middle of it, so you find your center, and you just connect every other corner, it'll look somewhat like a cube. So now at this point we can use this to help define these words. So an edge would be this would be an edge, or this would be an edge, because you see right here we have this square and this square, so these are each a face, and then you have your edges here, and right here would be the edge where these 2 faces meet. And then finally you would need your vertex, which would be, there's many of them. There's one here, 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 and that's the corner. This would be your vertex. Kind of the point where the edges meet. So you have all these edges here, and they all meet up there. So if I had to draw a net for this geometric solid here, you would draw it by you would first want to figure out what each face is. So this face is a rectangle, this one's a rectangle, and the one in the back is a rectangle. So they say the front right, the front left, and then the back. So they connected them like this, right? And then you have your rectangles, and they have the top, and then they have the bottom. But the bottom wouldn't actually go here. Sorry about that. The bottom wouldn't be able to go here. You'd have to actually, if you're going to draw a net, put the bottom here. So that way when you fold these all up, you could then fold in the triangles and create your top and bottom. Since these are equilateral triangles, the positioning of them won't really matter too much. But if they weren't equilateral and the sides are certain lengths, with how you position the triangles for the top or the bottom would matter. Now to get a little more in depth with working with geometric solids, I want to go over a couple more words. A rectangular prism is a prism that has rectangles as its bases. So you're looking at a geometric solid where its bases are rectangles. A prism itself would be a polyhedron or geometric solid with two parallel congruent faces, so those polygons.
Good morning, Michael.
Sorry about that, I got interrupted. A prism is a polyhedron with two parallel congruent faces called bases. The other face of the polyhedron are parallelograms and called lateral faces. So for this one, I'll go down to this example here. So like, let's talk about this. This is just a prism. It's not a rectangular prism because its bases right up here and right down here are triangles. They're not rectangles. So it has two parallel congruent faces, which are these two triangles. These are your bases, the triangle on the top, the triangle on the bottom. Then on these sides here, you end up with three lateral faces, and the lateral faces are all rectangles. This is also a prism which has its bases aligned one directly above the other and has lateral faces that are rectangles as a right prism. So since these triangles are right on top of each other, this is a right prism, and then the height is going to actually be the edge. But if you drew a line from the top all the way to the bottom that was perpendicular to both, that would be your height. Okay, so let's go ahead and talk about these words within this, describing this geometric solid or polyhedron. So describe the number of faces and lateral faces on the prism. So you would count them. The faces are just going to be your regular polygons. So 1, 2, 3, 4, 5. So there's 5 faces, 2 triangles, and 3 rectangles. And then it says the lateral faces. Those are just the rectangles that go up and down. Describe the number of vertices in the prism. So now you're just looking at your corners here. 1, 2, 3, 4, 5, 6. So there are 6 vertices. Describe the number of edges. So your edges would be wherever the faces meet. So you have 1, let me use a different color. 1, 2, 3, 4, 5, 6, 7. I already counted that one. 8, 9. So I've counted all 9. So there are 9 edges. Oops. Describe the shape at the base of the prism and name the prism. So it's a triangle, which would make it a triangular prism. So you name it based on the bases. So this is just, it's not that quick, but just how can I describe and work with geometric solids? We know a bunch of vocabulary about nets and just how to like name them and the different edges, vertices, faces, lateral faces, bases, things like that.